going to get to the nuts and bolts of doing solving for the value of x when we have an absolute value inequality. So the first thing that I want you to note is that our absolute value is not by itself. So I need to get this absolute value by itself. I don't care what's inside of it. And the other thing I might note is that when I read this, I have to wait until I get the absolute value by itself, which means I need to get rid of this first. So let's go ahead and subtract 1 from each side of the equation, and then that gives me my absolute value of whatever's inside is greater or equal to 6. Okay? So it's greater or equal to 6. So notice what I say. I say my absolute value is great or. Okay, because that's all I'm concerned about. Yes, there's an equal sign there, but it's great or. So that means this is an or problem. So that means I'm going to take it out of the absolute value. So I have 2x minus 3 is going to be something to negative 6, or 2x minus 3 is going to be greater or equal to 6. So notice I kept this the same. This is where it gets tricky. So this here is basically, I rewrite it the same without the absolute value marks. But this one here, because this is negative, means I have to flip my inequality. So this is going to be flipped. Because that is negative, I'm going to flip the inequality. Okay? So it's very important to keep in mind. So those, otherwise, it's just straightforward from here. So now I'm going to add 3 to both sides. And then that's going to give me 2x is less than or equal to, this becomes negative 3. So I divide both sides by 2. And I get x has to be less than or equal to negative 3/2. Here, same thing. I'm going to add 3 to both sides. So I get 2x is greater than or equal to 9, which gives me then that, divide by 2. So that gives me x is greater or equal to 9/2. This is an or problem. So that's basically how I would write my answer. But if I want to write it in set builder notation, I'm going to write it like this. The set of x such that x is less than or equal to 3/2 or x is greater than or equal to 9/2. Now, I'm going to graph this because if I graph it, it's going to make my interval notation easier to see what's going on. So because I only have one variable, x, I only have one line. I'm going to put 0 here in the center. Now, unlike the other one where I did all the number marks in between, I just need to know basically where they are. So negative 3/2 is somewhere to the left of 0, and 9/2 is positive, so it's somewhere to the right of 0. Okay, so we have an equal sign here, which means I'm going to have a closed dot. Or, if we remember from the previous video, or typically means that they go away, but not always. We're going to test it. So let's find some number on this side. Well, we have 0. We can always check 0. So let's just check 0. And if this is true, then we know it's going to be in the middle If it's not, we know it's going to be on the end. But we could always check some number out here, like -10, and out here, like 10. So this is not to scale by any means. So let's try 0. So when we go back into our original absolute value, okay, so let's test that. So what do I have? Notice I have to go back to where my absolute value, and we have to see if this is true. So let's plug in 0. So if I put in 2 times 0 minus 3 is greater than or equal to 6. 2 times 0 is 0, which means I have the absolute value of -3 is greater than or equal to 6. Absolute value of -3 is 3. So is 3 greater than or equal to 6? And the answer is no, which means 0 doesn't work. That's in the middle, so anything in the middle will not work. That means then that our answer goes out to the sides, okay? Which makes sense because -10 is smaller than -3/2, is what this is saying, and 10 is bigger than 9/2, which is what this is saying. But let's write this in interval notation. So interval notation, my arrow keeps going here forever. That's where x approaches -infinity, and my arrow keeps going there forever, and that's where x approaches +infinity. So with interval notation, I'm going to start at the far left, which means I'm going to start at -infinity, and I'm going to go all the way to -3/2. Because this is closed, I'm going to use that equal sign that's being held up by the stick. Then we have a gap. There's our gap. That means or. And then I start off again at 9/2. It includes 9/2, so I use my equal sign with the stick holding it up. And all the way to +infinity. So that's how we write set builder notation, interval notation, or just regular inequality notation.